So is my screen visible now? Okay, okay, thank you. So the topic that we are going to discuss today is actually about the third module, and this is functions. And everyone knows what a function is, right? In mathematics, we know what a function is. For example, we have two sets A and B, and if we have a function from A to B called f, then every element in A will be mapped to some element in B, right? So this is what we call a function. Probably this element is mapped to this one, this is mapped to this one, and this is mapped to this one, right? So this is what we call a function. And more conceptually, we can write a function as something like f of x, where x is an argument which is passed to the function and f is the name of the function f of x. I can write something like f of x is equal to x squared, and also I would write something like x belongs to the set of probably uh, the set of real numbers, sorry, the set of whole numbers or a set of integers. We will write a function, or we will define a function something like this: f of x is equal to x squared. This is a function that computes the square of any number which is passed to any integer which is passed to the function. As a result, we can say that f of 1 is equal to 1 square, which is 1. F of 2 is equal to 2 square, which is 4. F of 3 is equal to 3 square, which is 9, right? So this is how we we define a function and we use a function. This is what we call the definition of the function, right? This is the definition. The definition of the function f is in such a way that if it is passed with an argument or a parameter x, then it will return or compute the square of the argument, and it will return the squared value finally, right? So in C also, we have the same uh, concept of functions. In mathematics, if we write f of x is equal to x squared, in C, we know that we cannot simply write it like this. We have to use the syntax and semantics of a C program. So let's see how we can write the equivalent statements in C for the function f of x is equal to x squared. So this is what we are trying to do. So let me write it here. I have a I'm trying to write the equivalent statements in C for the mathematical function f of x is equal to x squared. Of course, we know the name of the function is actually f, right? This is the name of the function, and it is taking an argument x into this function, and it is returning an argument x squared back to the calling part, right? The name of the function is f, and see, the syntax of the function will be something like, everyone knows C is a strongly typed programming language. So whatever we are trying to define, we have to first provide the type of that particular thing. Here the name of the function is f. Okay, I write the name of the function as f. F is the name of the function. And what is the type of argument it is trying to take it into? We know that it is taking an argument x, right? And whenever we are specifying an argument, whenever we are specifying about a parameter, as C is a strongly typed programming language, we have to provide the type of the argument or the parameter. Argument and parameter, we use both these terms for the same purpose. We have to provide the type of the parameter. So let's assume that this function is taking only integers, right? These are all integers. The argument to the function are all integers. So I write something like int x. So this means f is the name of the function and x is the parameter which is passed to the function, and the type of the parameter is actually integer. I hope everyone knows what I am talking about. Then this is say if an x is passed to the function, it automatically computes x squared, right? So what about the return type of this function? We are passing integers into the function. 1, 2, 3, all these are integers, and automatically when 1 is passed, a 1 is returned. 2 is passed, 4 is returned. 3 is passed, 9 is returned. 4 is passed, then 16 will be returned, right? So if we are passing an integer, then the return value also will be integer, right? So what I write is, it is returning an integer. The function is always going to return an integer. So I write it here. Now you know what exactly have I defined in all these statements. So this is f is the name of the function, and x is the parameter into passed to the function or the argument to the function, and the type of the parameter is integer. And if we are passing an integer into the function f, it is going to return an integer value, right? So this is what we call the definition of the function, and the definition is not over yet. We have to say that f of x is equal to x square. Here in these statements, we have defined f of x. F of x we have written. Now we have to write, or we have to expand this function in such a way that it will return the value x squared. So we know that C is a block structured programming language, so everything has to be enclosed in braces. Now x is the one that has been passed to the function, right? Now it has to return an x square, or simply x times x. So what I write is, it returns x times x. So this is a statement and there is a semicolon. So this is the equivalent definition of f of x is equal to x squared in C. Does everyone understand this? Any question on this one? No. So let me check your comments. If you have got doubts or if you want me to explain more, please tell me. And checking your comments, can you tell me whether you understood this or not? Okay, Gopika. Ahmad Abdul Wahab. Okay. Anirudh. Okay. Akash. Right. Yeah. Nathan. Teja. Christy. Right. Yeah. Okay. Fine. So let me get back to the this part. So this is how we define a function, right? So now let me write the syntax or general way in which we are defining a function. So here it would be something like this. Int is actually called the return type, right? This is called the return type. So return type, then name of the function name, and in brackets that type 1 argument 1, right? So here you have, so there is not enough space to write all these things here, so I will write it here. So the general syntax will be something like return type, then the function name, then we have the argument here, right? Argument, each of these arguments will have the corresponding type also, that is type 1 arg1, then type 2 arg2. There can be multiple arguments passed to the function also, etc., right? And there is no semicolon at the end of this function statement, and then we open a brace here, then we have the different statements. Statement 1 semicolon, statement 2 semicolon, etc., some statement n. So these are all different statements of the function, and finally we close this, right? So this is how we define a function. Now let's so this is the general syntax of the function, or this is how we normally define a function. Now let's try to use this function. We have just defined a function called f. and the purpose of the function is to find the square of the function, square of the argument that has been passed to the function, right? So now let's write the void main part. I write the void main part here. I have the void main. I have a variable called x, and I read the variable scanf percentage d ampersand x. I read it. Then I am trying to I have one more variable here. I have a variable called x, and I have another variable called sqr. Then I find the square of the function using sqr assigns. F is the name of the function, right? F of x. So whatever passed to the function, whatever passed to the function f, or whatever the argument passed to the function f, the function will compute the square of the argument and it will return the squared value, right? So the squared value f of x means x is the one that is passed to the function, and f of x means the squared value will be returned, and the squared value is captured in the variable sqr. Now I am trying to print the value of sqr. Printf percentage d backslash n sqr. So this is how I write a program using a function to compute the square of a number, right? In this case, here you can see that this is void main index xqr scanf percentage d ampersand x. So for this x, I gave a value called 10, and then sqr assigns f of x. So the control now goes to this f of x. F of what will happen here? F of x. What is the value of x? It is 10, right? That is f of 10, and return x times x. That is, it will return 10 times 10. That is, what is 10 times 10? 10 times 10 will be 100. So it will return the value 100, and the value 100 will be captured in the variable sqr. And finally, I am printing the value of sqr. Now it is going to be, or the value that is going to be printed will be nothing but this 100. Does everyone understand this, or is it needed that I have to explain this topic a little more? I think all of you have already learned these topics in your Python classes. That is why I'm trying to go at a little faster pace. So does everyone understand this? Let me check your comments. Okay, Gopika, Nathan, Akash, Ahmad, right, Anamika, fine. Yeah, Rishikesh. So does anyone think that I need to explain this topic a little more? Anyway, we will be explaining this, or we will be going through these topics more and more. But is there anyone who doesn't understand the concept of this function? I hope no. So let's move on. Now let me write another function. I am erasing all these things. I have another thing. I am writing the same thing. Probably, yeah, I have this. I am writing the void main first. I am writing the void main first. Void main. I'm writing the same thing again. You have int x comma sqr, the previous thing itself. I am reading the value of x, scanf percentage d ampersand x. I'm reading the value of x. Then I am trying to find the square. Sqr assigns f of x. Then I'm trying to print the value of sqr. Printf percentage d backslash n sqr. The function f I haven't defined yet. Then that's enough. Now I am trying to define the function, right? So that is int f int x. So here I am returning x times x, right? Now, this is the same thing, or this is the same function that I had written in the previous example. There is no difference at all. But here, there is actually a little problem. There's actually a small problem. The problem is that it is the compiler. Everyone knows that C has got a compiler, right? So it will try to execute, or it will try to translate the statements of this program. Always it starts from the top. Here we have the void main. Okay, it understands what void main is. It is able to translate it into proper assembly language, right? Then it knows what x, it understands that x and sqr are integer type variables. Then it knows the scanf function, and the scanf percentage d ampersand x. It knows that it's a familiar thing. It has to read the value of x from the keyboard, right? Now, this statement sqr assigns f of x. Sqr, it knows it's an integer variable. That is fine. Assignment operator, it knows. Then x also, it understands what exactly x is, right? Here you have the x. And then you have this big thing, which is actually f. What is this f? For the compiler, we all know that it is a function, and the function has been defined a little downwards, right? But as the compiler is moving from top to bottom, it doesn't know what this f is. It doesn't understand what exactly this f is. So it will flag an error here, or it will raise an error here. So that is the problem with associated with this program. In the previous case, you had all these definitions at the top. I actually defined the function in the very beginning of the program, right? So as the compiler moves from top to bottom, first of all, it scans about all these functions, right? Then it understands that f is actually a function, and then somewhere later, if f is being used, then it knows that f is nothing more than a function. But in this case, that is the case that we are discussing now, it doesn't know what this f is. Even though f is written somewhere, or f is defined somewhere later, at this point of time, the compiler does not pick what this f is, and it will raise an error. And uh, so in order to avoid, or in order to remedy this situation, what we do is we will, even before this main, at some point here, we will tell the compiler that we have a function called f, and definition will follow later. You don't have to worry about this f. The definition of this function f will be there somewhere later in the program, so don't get confused. And to do so, we write a piece of statement here, and the statement will be something like, so here, first of all, we have to provide what the return type of this function. What is the return type of this function? The return type of this function is int. Int, what is the name of the function? F. And then we have to provide the data type of each of the variables which are passed to the function, or data type of all the arguments of the function. So there is only one argument to the function f, which is actually x, right? And what is the data type of that argument? It is nothing more than int. So we write the data type of the argument here, and then we put a semicolon. This is a semicolon. So the purpose of this statement is to tell the compiler that f is a function. The definition of the function will follow somewhere later, and f is taking only one argument, and the argument that it takes will be of integer data type. And finally, the return type of the function, or the function f, will return an integer value back to the calling program. So that is the purpose of this statement, and this is what we call function prototype. Function prototype. This is called a function prototype. The function prototype tells the compiler about the signature of the function, or what exactly the name of the function is, and what will be the different data, how many arguments are passed to the function, and what are the data types of each of these arguments, and finally what will be the return type of the function. So this is what we call function prototype, and this is what you call function definition. This is what you call function definition. And finally, there is one more thing. This is the point where the function is being called, right? And this is what you call invoking the function. This is what you call invoking the function, right? So we have three things. You have the function prototype, which tells the compiler about the signature of the function. Then you have the function definition, which actually contains the original definition of the function, or what exactly the function does. That is what you call function definition. And finally, you have invoking the function. That means you are simply calling the function there, right? And so does everyone understand this concept? Let me once again check your comments. Okay, Nathan. Anamika, okay, okay, Ahmad Abdul Wahab, right? Yeah, chalo. ഇല്ല, അത് കറക്റ്റ് ആണ്. അതാണ് നമ്മൾ ആദ്യം ചെയ്തത്. ഫംഗ്ഷൻ ഡെഫിനിഷൻ തന്നെ നമ്മൾ മുകളിൽ കൊടുക്കുകയാണ് ചെയ്തത്. അത് തെറ്റില്ല, പക്ഷെ നമ്മൾ എപ്പോഴെങ്കിലും ഫംഗ്ഷൻ അതായത് ഇൻവോക്ക് ചെയ്യുന്ന പാർട്ടിന് ശേഷം, ഇൻവോക്ക് ചെയ്തതിന് ശേഷമാണ് ഫംഗ്ഷണൽ ഡെഫിനിഷൻ വരുന്നതെങ്കിൽ നമ്മൾ ഫംഗ്ഷൻ പ്രോട്ടോടൈപ്പ് കൊടുത്തിരിക്കണം. ഇല്ല എങ്കിൽ കുഴപ്പമില്ല. ഇൻവോക്ക് ചെയ്യുന്നതിന് മുമ്പ് തന്നെ ഫംഗ്ഷണൽ ഡെഫിനിഷൻ ഉണ്ടെങ്കിൽ കുഴപ്പമില്ല. ഓക്കെ, അതെ 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 അതിനു വേണ്ടിയിട്ടാണ് മാറ്റിയത്. പക്ഷെ കൂടുതൽ പ്രോഗ്രാമേഴ്സും ഈ രീതിയാണ് പ്രിഫർ ചെയ്യുന്നത് എപ്പോഴും. I will tell you an example. You may be wondering, say when you are using this function strlen. Strlen is actually a built-in function in C, right? When you are using this strlen, you always include something like a hash include string.h, right? And the thing is that it is in this string.h the prototype of the function strlen is defined. So it is more or less like you have the string.h. This is string.h. This contains a number of prototypes. So you have a int strlen, say string, something like this. So this is how the prototype of strlen has been defined. So all the string functions have their prototypes defined in string.h. And when this hash includes string.h is written even before the void main, even before this void main, then what actually happens is all these function prototypes are replacing this hash include string.h, or these function prototypes are appearing even before this void main. That is why we have to include these kind of string.h. Similar is the case with stdio.h. You have this printf, scanf, all these things are actually built-in functions in C, and the prototypes of all these built-in functions are defined in stdio.h. That is why you are placing this hash include stdio.h at the beginning of every C program. So does everyone understand this topic? Does everyone understand this concept? Okay, Ahmad Gobiga, fine. Prince Teja, right. Now, if this is the case, let's move into something more interesting. Yeah, let me erase all these things. Let's try to develop a function that will be able to compute the sum of two numbers. So function, you have a function called a sum that computes the sum of two numbers. in mathematical ways, or mathematically I can write something like sum a comma b assigns simply a plus b, right? uh, for all a comma b in set of integers, right? Sum a comma b assigns simply a plus b. So this simply computes the sum of two numbers. So how will you translate this into C program statements? I can write it something like, you know that sum is this is the name of the function, and these are the different arguments passed to the function, right? And these arguments, you have A and you have B, and the data type of both these arguments uh, is actually integer, right? Integer, and it is returning a plus b. So what will be the return data type? What will be the uh, re return data type? That is also integer, right? So I write it something like the return type will be integer, and the name of the function is sum, and it is taking two arguments a and b, and the data type of a is also integer, and the data type of b is also integer, right? Uh, so here it is simply returning a plus b. A plus b it returns means, how can I write? It simply returns a plus b. Return a plus b. It returns. That's enough. Now I have this void main. Uh, void main. So here I have probably I write three variables here, int a, int b, and int s, right? I read the values of both a and b. Scanf percentage d, percentage d, and a and b. I read all these values here, right? Then what I am doing is I am trying to find. I am computing the sum. How do I compute the sum? Yes, assigns the name of the function is sum, right? I can simply use the function sum here, sum, and I need to pass the arguments. What are the arguments? They are both a and b, right? So I have computed the sum, yeah, using the function this sum, and the value has been captured, or the summed up value has been captured in the variable s. Now I can print the value of s, right? So print of percentage d, probably backslash n, percentage d backslash n, yes, and that's enough. So this is how I make use of a function. So here I don't need to use a prototype, because what is the reason that I need not use a prototype here? Because this is the place, this is the place the function is invoked, and this is the place the function has been declared, right? So the place of invocation is later than the place of definition. So that is why I don't have to use a prototype. Otherwise I should have used a prototype here. And even now there is no problem in using an extra prototype at the beginning of the program. So that doesn't make any difference. So has everyone understood this program? Yeah. Okay, Deepak, Nathan, Ahmad, Angel, right. Right. Now, let's write a little more complicated function here. So what I am trying to do is, I am using, I am trying to define a function like, say, f of, or well, f of a comma b. I am returning, I have two parts here. The first is a minus b if a greater than b. It is b minus a otherwise. So it is something like, this is the mathematical function that I need. uh, I have two arguments, so two parameters, a and b. I will return a minus b if a is greater than b, otherwise I will return b minus a, right? So for example, it will be something like, I am passing something like f of 10 comma 5. Here the first argument is a, second argument is b, right? Here a is greater than b, it will return a minus b, that is it will return 5. On the other hand, if I give something like f of 5 comma 10, here we know that the a greater than b, this part, the first part will not work because a is not greater than b, right? A is 5 and b is 10. A is not greater than b, so we have to go to the otherwise part, and in this case otherwise it is what? It is b minus a. B minus a means 10 minus 5, it is actually 5. So what is this function called? What kind of a function is this? What kind of a function is this? What kind of a function is this, or what exactly is this function doing? It is in fact finding the absolute difference between two variables, right? It is finding the absolute difference, correct? Right? It is finding the absolute difference. So instead of let me write it as a meaningful name. Instead of this f, I will write it like abs diff. This is the absolute difference, abs diff. So how will you how will you define the function here? What is the way to write this function? So here what I do is something like I have the name of the function is absolute difference, and the variables or the parameters that I am taking into this function are both a and b, and what will be the data type of this a and b? They are both integers, right? And what is the return type? Return value can be either a minus b or b minus a, right? And we know that this also will be integer. So the definition of the function will be something like int absolute difference. You have two arguments, a and int b, right? And then I have to first of all I need to check this condition. If a is greater than b, it will return a minus b. If a greater than b, return a minus b, else return b minus a. So this is how you define this function. So whatever you have in this mathematical terms, you just need to convert it into C programming statements. That's the only thing that you have to do. So this is how you define this function, right? Then if you have this void main here, void main, say you have int a, b, probably some c here. What I write is c assigns absolute, oh no, sorry, I need to read the values of both a and b, right? Scanf percentage d, percentage d, ampersand a, ampersand b. I am reading the values of both this a and b. Then I am finding the value of c as absolute difference. I am calling this function absolute difference, a comma b, right? Then I need to print the value of c, that is printf percentage d backslash n c. That's enough. So does everyone understand this concept of functions? Does everyone understand this absolute difference function? So if the value of a is read as 20 and the value of b is read as 80, then automatically so here we have a b c. Let me explain this in a little more explicit way. Let's start from the void main. So the execution normally starts from this void main, and I have int abc. So whenever you have this int abc, this is a, this is b, and this is c, right? And maybe three memory locations are reserved for holding the values of all these things. Say this is stored at location 1000, or this is the integer location starting from 1000. this is from 2000 and this is from 3000 actually. So scan of percentage d, ampersand a, ampersand b. Suppose for A the user input 10 and for B the user input 80, then C assigns absolute difference AB, right? C assigns absolute difference AB. So the value, the now we have to go to this absolute difference function with the arguments 10 for A and 80 for B, right? 10 for A and 80 for B, and whatever value returned by this absolute function should be saved in or should be stored in this variable C, right? So this is how this function has to work. That means we have to go to this absolute difference function. So we are going to this absolute difference function with two values, 10 for A and 80 for B, right? Now there is an important thing that you have to understand, right? When it comes to this absolute difference, when it comes to this function, when it comes here, you have int A and int B, right? So you have two parameters passed here. You have two parameters, or you have two arguments passed here, A and B, right? And you have to understand that whenever parameters are passed to a function, there will be separate memory locations allocated for those arguments. There will be separate memory locations. In other words, this A and this B, that is this A and this B, they are not the same. They may have similar values, but in the case of memory locations, they are different. Or let me make it less complicated. Whenever you have arguments passed to this function, these arguments will have their own memory area. That is this A. That is why I am writing in the left hand part itself. So you have an A here. This is A, and this may be at location 7000. You have a B here. This may be at location probably 8000. So you will have separate memory locations for the arguments which are there in the definition of a function, or the parameters which are there in the definition of a function. Here you have A and B in the definition of a function as arguments, and they will have separate memory locations. And what we have called is ABS diff 1080, right? ABS diff 1080 means, what is the first argument? A. That is, A will get the value 10 and B will get the value 80. So A will get the value 10 and B will get the value 80. Now what we are checking is, if A greater than B, which A should I check? On the left hand side or on the right hand side? On the right hand side, the variables actually belong to the main function. On the left hand side, the variables belong to the absolute difference function, right? Both are different. They may have same values, but memory wise they are occupying different areas. Now we are checking if A greater than B. If A greater than B, we are checking in absolute difference function, and A belongs to the A that belongs to the absolute difference function is this one, and B that belongs to the absolute difference function is this one. So what we are checking is if A greater than B. Is 10 greater than 80? No, 10 is not greater than 80, right? 10 is not greater than 80. Now that means we have to go to the else part. In the else part, we have written B minus A. That is, B minus A means what? B minus A is 80 minus 10, which is actually 70. This function returns as 70, and the returned value, it is from this location that we actually called this function, right? So this absolute difference 10 comma 80 has returned a value 70, and the returned value will be captured in the C here, 70. Now printf percentage d backslash and C. So which C are we printing? We are printing the C in the main function, right? So we are printing the value 70 here. So do you understand this concept? What I was trying to explain was like, See, whenever we have arguments which are passed to a function, they will have their own memory space. They will have their own memory area. And the memory area will not be shared between two variables of two different functions. That is not possible. So, do you understand this? If you understood this, I have another thing that I need to explain. So, do you understand this concept? Yeah, Akash, right? Ahmad, Gopika, fine. Nathan, right. So, Teja, right. So, if this is the case, let me write a function and you have to provide the uh, answer for that function. You have to provide the result of that particular program. So, I have something like probably I have well, int sqr. This is a dummy function, right? Int, this is the prototype. I have this void main int a b scan of percentage d and a. I am reading the value of a. Then I am computing the value of b here. That is b assigns sqr probably a. Then I am printing the values here. Printf percentage d backslash and a. I am printing a. Printf percentage d backslash and b. I am printing both a and b here. That's all. Then I have similarly I have the function here, which is sqr, right? So int sqr int a. I am say uh, what I am doing is I am just doing something like a assigns probably 0, return a times a. So this is a kind of dummy function. It is not actually doing anything valid. So you go through this program? Can you go through these functions and identify what exactly these functions are doing? And one more thing is that I am trying to invoke. I am trying to, in this case, I am trying to give a value 10 for this a. I am trying to give a value. I am trying to here in this scanf part, this a, I am assigning a value 10. Can you predict what exactly the output will be? So you know that there are two different printf statements, so there will be two different values printed. So can you find out what are the different values printed here? Can you type the values in the comment? Just moving to the comment part. Joan 10 0, okay, 10 0, 10 0, right? Yeah. So let me explain this program once again. Here, let's draw the memory map as usual. So everyone knows that, yeah, everyone knows that this part. Everyone knows that this is the actually the prototype int sqr int. I have defined this prototype because my function definition is after my function invocation, right? That is why I have written this thing. So let me keep it aside. Now I start from this void main int AB. So whenever you see that there are variable declarations, so you have A here, maybe this is A, this is in location 1000, and you have D, this is in location probably 1500, right? And scanf percentage D A, I am reading a value for A into this particular location. The value that I am reading is actually 10. Now B assigns sqr A, that is I am calling the function. This is the point from here. I am taking the control to this function sqr int A, right? So here you know that we have a variable, we have a parameter, or we have an argument here, and here you have this A. This is defined in location probably 1000, right? And what I have called is this is something like a B assigns sqr10. This is what I have called, right? So the value 10 will be used for this argument A, that is the value A gets this 10, right? Now in the next statement what I am doing is A assigns 0. I am just changing the value of A to 0. This 10 is now replaced with 0. This 10 is now replaced with 0. Return A times A, that is 0 times 0, that I am returning. 0 times 0 is nothing but 0, right? 0 I am returning, and that 0 will be captured in the variable B here. That is the variable B gets the value 0, right? Now printf percentage d backslash n A. Which A am I printing? The A on the left hand side, not the A on the right hand side. A on the right hand side is actually for the function sqr only. I am printing the A in the main function, and that has got the value 10, right? And A gets the value 10, and printf percentage d backslash B gets the value 0. So the result that is printed will be 10 0. This will be the result. So does everyone understand this? Okay, Akash, fine. Ahmad, Nathan. Right. I think I have given you an overview about the functions in C. It is just a mathematical translation. It's just a C program. It's just a translation of any mathematical function into a C program. That is the concept of functions in C. And we have defined functions here. We have defined some functions like functions for adding two numbers, for finding the absolute difference between two numbers, right? Or to find the square of a number. And we have seen the general format of a function definition. And then we have seen three different things: function prototype, function invocation, and function definitions, right? And then we have seen that the variables in two different functions, even though they share the same name, they are not the same, right? They have different memory areas, and they are not using they are not sharing the same memory locations. They may have same values, but the memory locations that they are using will be different, and this is what you call passing by value. This I will explain later, but for the time being, let's understand that there is a concept called passing by value, and it is the concept that is used by a C program. So let's wind up our class for today, and we will see more about these functions in coming classes.